In this video, we're going to look at a special kind of sequences, and we're going to focus on arithmetic sequences. Arithmetic sequences, they represent a set of numbers that follow a linear pattern. So basically, linear patterns mean that I'm going to be constantly adding or subtracting by the same number every time to get from one number to the next. And we call that number we add and subtract by the common sum or common difference. And there's a couple of ways we can write arithmetic sequences. Recursively, since we're constantly adding or subtracting the same number, to get from one number to the next number, you take the previous term and add whatever your common sum or difference is to it. Explicitly, we can define this function. This looks an awful lot like the way we write the equation of a line, where to get the next number, you take the number that you know, in this case a1, plus d times n minus 1, where a1 is the first term, d is the common sum or difference, and then we would plug in for n and we'd get whatever term we wanted. So let's apply that here to this example we have right up here below it. We've got a couple of things we want to do. So first of all, let's look at the sequence that we're given, and we go from negative 26 to negative 20 to negative 14 to negative 8. Find the next four numbers. We'll find our pattern. To go from negative 26 to negative 20, we add 6. To go from negative 20 to negative 14, we add 6. To go from negative 14 to negative 8, we add 6. So what we're doing every time is we're adding 6. So my next number, if I continued that on, my next number would be negative 8 plus 6, which is negative 2. And then I would add 6 to that, and I would get 4. And then I would add 6 to that, I would get 10. And then I'd do that again, I get 16. And so we just continue, this would continue on forever. Now recursively, our recursive formula, the first number we were given was negative 26. To get from one number to the next, so an would equal, take the previous term, an minus 1, and apply your d to it, your common difference. Well, our d is adding 6 each time. Now, explicitly, the explicit formula, an equals a1 plus d times n minus 1. Well, a1 is the first number in our sequence, which is negative 26. D, we said, was positive 6. So all we would do is we would plug in, and we would have our explicit equation. So explicitly, the sequence is defined as negative 26 plus 6 times n minus 1. We can use that explicitly defined function to find any term we wanted to know. So the 23rd term, instead of just copying this sequence out until I get to the 23rd time, all I would need to do is put in 23 for n and evaluate into our explicit equation. So we'd have negative 26 plus 6 times 23 minus 1, and then we would just evaluate that to get an answer. And we'd wind up getting the 23rd term, so A23 is going to equal 106. All right, next one. So we get two different kinds of problems here. So we're still talking about an arithmetic sequence. We want to find the first four numbers and the explicit formula for what's given. And now this first problem on the left-hand side, what I'm given is, well, I know that the 34th term is negative 635, and the common difference is negative 20. And so what we would do here is, well, let's try to figure out what the first term is. We're going to take our explicit formula, which is an equals a1 plus d times n minus 1. The only thing that I know is I know that when n is 34, I'm supposed to equal negative 635. So I'm going to put 34 in for the n and say a34 is equal to a1 plus d times 34 minus 1. Well, we know d is negative 20 and a34 is negative 635. So negative 635 is equal to a1 minus 20 times 34 minus 1, which is 33. And then we would work our way. We just would solve for a1. And we'd get a1 is going to equal 25. And so we can, right now, determine our explicit equation because we know a1 and our common difference. So the explicit form of this sequence would be an equals 25 minus 20 times n minus 1. There's our explicit equation. Now, they want us to find the first four numbers of this sequence. So my first four numbers of this sequence, well, we know that the first term was 25. to find our second number, we just apply your common difference, so subtract 20 from that. So 25 minus 20 gives me 5. My third term, subtract 20 from it, I get negative 15. And in my fourth term, subtract 20 from that, I get negative 35. There's the first four numbers of that sequence there. Now let's look at the second one here on the right-hand side. So this time I'm not given D nor the first term. I'm given two random terms. I know that the 13th term is negative 104 and the 31st term is negative 284. So what we're going to do is we're going to start with our explicit formula still. So AN equals A1 plus D times N minus 1. We're going to use the two terms that we're given. So we're going to use the last known term, A31, and we're going to put that where AN is. So I'm going to say A31 is equal to, and our earliest known term, which is A13, is going to go where A1 is. So A31 is equal to A13 plus D times, now what I did was, by doing this, we replaced N with 31, and we replaced 1 with 13. So inside of parentheses, we'll have 31 minus 13. And now we're going to replace A31 and 13 with values. So A31, so negative 284, is equal to negative 104 plus D times 31 minus 13. And we would just work our way, and we would solve for D after doing that. So I'd add the 104 to the other side. And then after that, we would divide by 31 minus 13, and we would get our answer for D. And D is going to wind up being negative 10. So we know what D is. Now that we know what D is, we're going to do what we did in the previous problem, and we're going to take our explicit form, which all we know now is that D is negative 10, and we need to solve for our first term. Well, let's pick one of the two terms we're given. I'm just going to use term 13 and put in 13 for the ends. So A13 is going to equal my first term minus 10 times 13 minus 1. And so we know A13 is negative 104. So negative 104 is equal to A1 minus 10 times 13 minus 1, or 12. And we go solve for our first term. So negative 104, we'd add 120 to the other side, and we get our first term to be 16. So now we know all of the parts for our explicitly defined function. And so what we'd have is AN would equal, our explicit form would be 16 minus 10 times N minus 1. Now, since we wanted to also write the first four terms, the first term was 16, so the second term, I just subtract 10 from it, so we got 16, then we got 6, subtract 10 again, negative 4, subtract 10 again would be negative 14, and then this would continue on forever.